here to Humboldt-University's economics department on the occasion of the 6th Hermann Otto Hirschfeld lecture. Hermann Otto Hirschfeld was a PhD student here in Berlin. He graduated from this very university in the beginning of the 20th century, 1912, I suppose. And he gave his name, well, his name was given to this series of lectures, which started in 2003. We have since had a number of distinguished lecturers, including Joel Horowitz, Paul Embrechts, interested in mathematics right from his early careers in his life. I don't have to go through all of this in that much detail because last year's attendants will know that this was discussed in some detail by Mrs. Vogt, who will take over from me and talk a little bit more about the history behind Hermann Otto Hirschfeld after I'm finished with this here. He graduated from Humboldt-University, as I said, went on to a number of places and at Duke University, so not too far away from Princeton after all. And coming to Princeton and coming to Yassin Zahalia, I would like to mention, well, a few steps in his career. At the moment, he is Professor Otto Hack, professor in the Department of Economics at Princeton University, this very distinguished economics department that yet again won a Nobel Prize this year. He is also director of the Bentheim Center for Finance, and as such, of course, a close relative in a sense to where I'm coming from, because my background is the Quantitative Products Laboratory here in Berlin that is at this year for the first time co-sponsoring with CASE, that is organizing this lecture series here. Yassin started out as an undergraduate at École Polytechnique in Paris. He did a BS in math back there. He moved on to do economics and statistics. Again, there's a parallel, at least as far as statistics goes, with Hermann Otto Hirschfeld at the École Normale de, ENSAE. Let me just stick with the abbreviation in Paris. And then he did a PhD at MIT in economics, and after that became an assistant professor, associate professor, and full professor at the University of Chicago. All of this within 5 years. And then he moved on to become a professor at, well, as I said, Princeton University in '98. Each step in his career was marked by a number of honors. For instance, he was awarded the honor, well, he gained the merit for being the best, for writing the best undergraduate thesis at École Polytechnique, this very distinguished Grande École. At MIT, he had a doctoral fellowship, and he is an elected fellow of a number of societies. This includes the IMS, the American Statistical Association and the Geometric Society. He has won an Alfred P. Sloan Fellowship and was a Guggenheim Fellow for 2 years, 2006 to 2007. He is currently editor of a number of distinguished journals, including Econometrica, Journal of Finance was something that he was working with, and also Finance and Stochastics, I should mention. As a financial mathematician, I'm particularly pleased to have him among our ranks as well. His research interests include a wide range of topics, from mathematics to economics to econometrics and statistics, and it's very well documented by his very recent publications. If you go on his webpage, check what are the forthcoming articles, you will find 2 of them in the Annals of Statistics, 1 of them in the Annals of Applied Probability, 1 of them in the Annals of Applied Statistics, another one in the Journal of Econometrics, and there's another article which has just appeared in Econometrica, and I think this already shows that there's a wide range of interest by Professor Yassin Zahalia, and well, he excels, of course, in his endeavors as documented by that success in publications. Another success has to be mentioned. He was awarded the Emory Williams Award for Excellence in Teaching at the Graduate Business School in Chicago, which is a challenge to win, I think, because these guys are really demanding over there in the business schools, and if you want to get recognized for your teaching, you have to do it really well. And so I'm very pleased that we have him here, because we can not only look forward to research at the highest level, but also teaching at the highest level. So thank you very much, Yassin, for being with us today. We are looking forward to having your theories here. And with that, I think I can pass on to Professor Hertle, for the, let's say, formal parts of this event. Thank you.
I'm not so tall, right? So I'm only a statistician. He's a mathematician. But I started off as a mathematician. Maybe I became smaller during my lifetime. Okay, thanks, Peter, for this very nice introduction. So I didn't have to do it. You presented Yassin already in his CV in great detail, and it is now my honor to present to Yassin the Diploma, German word Urkunde, of this today's Hermann Otto Hirschfeld lecture. Please come here. This is you may open it now, you may open it anytime. It is an idea of the Center for Applied Statistics and Economics, a joint interdisciplinary center of the Humboldt-University. It contains projects of mathematics, but also of agricultural sciences, and maybe in future also of theological sciences, and the law school is integrated. So we have a broad interdisciplinary character.
Thank you, it's beautiful.
Okay. Okay, and then it is our tradition, you don't get that because it's too heavy for the airplane, but it's our tradition to engrave all the former Hermann Otto Hirschfeld lecturers here. So, and the traditional photo goes like that we are standing here, and maybe since it is QPL, you should stand here as well. We make a sequence, and then Annette, you are the next. Maybe you should hold it, right? Okay. So we all have to say Hermann Otto Hirschfeld.
To sing or to say?
To
sing or to say?
Yassin is more friendly.
Because we are in the chapel, so we have to sing it, perhaps.
Okay. Fine.
No.
Thank you.
No?
Okay, memoristic, exhausted. Okay, thank you very much.
Thank you.
So this is the official begin.
So I have to give that back to you.
Sorry, you have to give that back. I'm sorry for that. That's property. Okay, it's my pleasure now to welcome Annette Vogt from the Max Planck Institute for Wissenschaftsgeschichte, History of Science, and she will give an introduction on the life of Hermann Otto Hirschfeld. So let's welcome her for this talk.
So, good afternoon, everybody. And it's an honor to say something about Hermann Otto Hirschfeld, H.O.H. Hartley, who he was and why we are together and to have this Hirschfeld lecture. So, in memoriam of Hirschfeld Hartley, that means we have to consider his life and fate and of an extraordinary statistician. H.O.H., as he was called by friends, was one of the most interesting statisticians in the 20th century, and one who was able to combine pure and applied methods, who was able to solve simple practical problems as well as to create new topics. And he also is famous because he made voluminous table works. Hermann Otto Hirschfeld Hartley was an organizer in science too. In 1963, he established his Institute of Statistics at the Texas A&M University, which became one of the centers of statistics in the USA. And I quote, as William Smith pointed out, he was a great mentor not only to his students, but also to his colleagues. At the Texas A&M University, an annual Hartley Award is given from 1980 onwards, and the Hartley Memorial Lectures are held every other year from 1988. The Hermann Otto Hirschfeld Lectures here at the Humboldt-University was established in 2003. And with these lectures, Hartley comes back to the town where he was born and where he received his PhD in mathematics shortly before he was forced to leave Germany and to go into exile. So born in a Jewish family, German Jewish family, Hartley Hirschfeld had to change his life after 1933 completely. And that was because of the Nazi regime in Germany. And last year, before the Hirschfeld lecture, I gave an introduction in his life and his fate, so I don't want to repeat everything of that. So who would like to have the lecture of the last year, please send me an email, and so I will send you then the copy of the lecture. And he made more or less 2 times a change in his life, because first he emigrated to Great Britain, and then later, after 1945, he moved to the US, which was not an emigration, of course, but because of the different scientific cultures of both countries, it was a change too. Before January 1933, Hermann Otto Hirschfeld got the good education children of bourgeois family got in these years. He was at the gymnasium, first at the Kant Gymnasium, and then at the Gymnasium Bismarck Gymnasium in Wilmersdorf. And here one teacher of mathematics influenced him, Richard Fuchs. And this is the son of Emanuel Lazarus Fuchs. He was a professor for mathematics here at the Berlin University. After finishing the gymnasium, Hirschfeld studied mathematics, first at the university in Göttingen, the mecca of mathematicians and physicists in the early decades of the 20th century, and then he moved to Berlin. In Göttingen, he was mostly influenced by Richard Kurang, later an emigre too. Probably he changed the university because of the beginning Nazi terror. In the little town Göttingen, SA troops marched very loud and more visible than in Berlin, where still anti-Nazi forces were active. In Göttingen, the famous Emmy Noether had to change her apartment already in 1932 because she was a Jew and a left-wing and voted for Social Democrats. The capital, Berlin, was less dominated by the Nazis, although in Berlin SA troops marched through parts of the town too. Jewish people or human beings who looked Jewish were beaten, and in the case of foreigners it was a little scandal and reported in newspapers. And who wanted to see the danger could see and could recognize it. Among the first were the writers Josef Roth and Kurt Tucholsky. Hirschfeld could finish his studies. 2 years later, it was forbidden for him, for every Jew by Nazi definition, and independently of baptization, like in the case of Hirschfeld or the others, and the Nazi definition of non-Aryan was the reason to exclude everybody then with Jewish roots from any state institutions. He studied very quickly in Berlin, finished his PhD and got his doctoral degree, and his thesis was on the topic Direkte Methoden der Variationsrechnung zur Lösung von Randwertproblemen, so direct methods of variational calculus to solve boundary value problems. And the thesis was published in the series of the Mathematical Institute, Schriften des Mathematischen Seminars und des Instituts für angewandte Mathematik der Universität Berlin. The reference of the thesis was written by Adolf Hammerstein and Erhard Schmidt. Erhard Schmidt, another famous mathematician of the Berlin University. And Erhard Schmidt, many, many years later, remembered that the nicest result Hirschfeld had covered in one footnote, I quote, sein schönstes Ergebnis hat in einer Fußnote versteckt. Of course, when I read it, I tried to make it clear, and I studied the whole thesis of Hermann Otto Hirschfeld, but it was impossible for me to clarify Schmidt's bonbon, and one has to say unusual for that time, the thesis of Hirschfeld include 37 footnotes. After getting his doctor diploma, and it was on May 9 in 1934, Hirschfeld was able to leave Berlin, and he had to leave Germany and to get the uncertain way into exile. His career began at the Berlin University, but it was abruptly ended, and like many scientists with Jewish roots, Hermann Otto Hirschfeld was forced to flee Germany. And I would like to remember here only from the Berlin University, the Berlin Technical College, Technische Hochschule, were fired because of the Nazi policy 22 mathematicians, 3 women and 19 men. The procedure of displacing, it was called then later in London, of displacing people from schools, technical colleges, universities, also from the Kaiser Wilhelm Institutes, was part of the Nazi policy and against all liberals and democratic people, against left-wing persons, and especially against the Jew. The anti-Semitism of the Nazis was a racist one with elements of old stereotypes combined with modern methods of discrimination and administration and bureaucracy. So Hermann Otto Hirschfeld first went to London and then from London to Texas, but he escaped, and fortunately it was possible for him not only to work and to teach in his exile, but becoming an extraordinary statistician and scientist. The mathematician Maximilian Pinel and he was prosecuted by the Nazis too. He was the first to study it in Germany, one has to say in the old Federal Republic of Germany, the fate of Jewish mathematicians and left-wings who were thrown out by the Nazis and who were persecuted. And from 1969 until 1974, he published his results in the annual report in the Jahresberichte of the German Mathematical Union. And it was about 15 years before another important publication came out. So he was really the first. And he had still the luck to be in contact with Hermann Otto Hirschfeld. And you see, he wrote all the names on the mathematicians who had to go into exile. And in most of the case, in 1969, they were still alive, so Maximilian Pinel could exchange information with them. And this is the small entry about Hermann Otto Hirschfeld. Später, later, Hartley. But although he was in personal contacts, Maximilian Pinel got no private information. Hirschfeld Hartley was very quiet, even in his own family. Nothing to speak about the time in Germany, what was happened and what happened with the family. And then this dictionary came out from 1981 until 1983, and Hermann Otto Hirschfeld has not the smallest position at the Berlin University, so he was not included in the list of displaced German scholars, which was published in London in 1936 by the Academic Assistance Council. It was an organization established in 1933 to help German emigres and later to help emigres from all Europe. And of course he is here in the dictionary, and the dictionary based on this list, but also on questionnaires to the emigres who lived in the whole world then because of the Nazis and the Second World War and what happened. So, and here when you see the entry which is made, and so please believe me because I'm studying very often the fate of emigres, this is an unusual one because you have no personal information. Even that he was married and has 2 children is not included here. Normally one has to say in the other entries these personal informations are included. So Hermann Otto Hirschfeld emigrated in 1934 together with his brother Philip, an advocate and solicitor. They emigrated to Great Britain because their grandfather had connections to Great Britain. The grandfather was a merchant and he was very often in London, so there were still some personal relations, and so it was easier for them. And the mother and the other children followed in 1938, and in the same year the father died in Berlin. He don't wanted to emigrate, and luckily he could die in his bed in 1938. And then Philip and Hermann Otto Hirschfeld, they changed their name into Hartley in 1937. They became British citizens, so that made the life much easier. Other emigres were stateless or still Germans, and then in autumn 1939, with the beginning of the Second World War, many of them were arrested as enemy allies. So this didn't happen with them, of course. Obviously, because of the different conditions for mathematicians in Great Britain, Hartley changed his scientific interests from pure mathematics to applied mathematics and statistics. And like HOH, many emigres had to do so, and the younger emigres studied again like he did. So he began postgraduate studies at Cambridge University. Very soon he published 4 papers, and in 1940 he obtained a kind of second PhD in mathematical statistics from Cambridge University. Only little mathematics was demanded when Hartley became a statistician between 1936 and 1938 at the Harper Adams Agricultural College in Shropshire. And here he was involved with experiments. He lectured on statistical methods to students of agriculture, and soon he became a consulting statistician. And here also HOH met his future wife and lifelong support, Grace, and in 1940 they married and 2 children were born in London. So, and in London and in England, he became a so-called table maker. So in 1938, he joined a company called Scientific Computing Service, and the company was founded by Leslie John Conway, who was known very well by Carl Pearson, and the son of Carl Pearson, Egon Pearson, later on became a close friend of Hartley and a collaborator and a close colleague. And who knows already the books on tables, biometrica tables, you know, these were the authors of that. So when you have to make tables, you can go to the old history, to astronomy and to Staatenkunde. And I took 2 examples from this book because the author of the book, Stephen Stiegler, was a Hirschfeld lecturist here too. And I recommend everybody who is interested in history of statistics the book. And here you have one example how a table looks, typically one about death rates. This is made very early in most of the countries and belongs, in Germany, belong to Staatenkunde, Staatswissenschaften. And here you have another one, different values reported for the astronomical unit. So these are the kind of tables which were existing in the time when HOH became a table maker in astronomy over some centuries, in Staatenkunde only 1 century, and it started also in agriculture. So that is the reason that Hirschfeld Hartley was involved to make tables. So, and I said already Conway was known with Carl Pearson, and Conway was not only a table maker, he was named by Herbert Aaron David in the obituary on HOH. Carl Pearson was the most famous statistician in Great Britain. He had a chair at the University College London, and unusually his son became the chair then of the father, so Egon Sharp Pearson. So this is Leslie John Conway, who was an astronomer and a pioneer in mechanical computation. Therefore, he was one of the best specialists in his time to make tables. In 1928, he wrote an article on the construction of tables by interpolation. He described at length a laborious and error-prone procedure for interpolating numeric table values by desktop calculator, and then how to use this with punched cards, a tabulating machine, and a sorter for greater speed. And he also tried already to use the Hollywood machines. Conway was born in New Zealand, studied at Auckland University College, London. There he met Carl Pearson, and at Cambridge University, where he received the PhD in astronomy. In the early 1920s, he worked in the USA, teaching numerical analysis at Swarthmore College and Northwestern University. In 1926, he joined His Majesty's Nautical Almanac Office in Greenwich, and here he was superintendent of the Almanac Office. And this he was from 1930 until 1936. So he really was an expert with a lot of experience to make tables. He was a pioneer in the application of punched card machinery to astronomical calculations and the production of astronomical and mathematical tables. He was the first to turn punched card equipment to scientific use and the computation of astronomical tables by the method of finite differences, as it made already 100 years before, or tried to make, by Charles Babbage. In an article in May 1932, The Application of the Hollywood Tabulating Machine to Brown's Tables of the Moon, Comrie described his punch card methods in greater details, and with paragraphs given the function and operation of each component. And he also gave a description what we are saying today, programming in, and in his term it was automatic control. Comrie died already in 1950. Shortly before his death, he was elected as Fellow of the Royal Society, London. And Comrie became a kind of advisor, supporter of the young émigré Hartley. Comrie founded his scientific computing service in the winter 1936-37, and in 1938, Hartley joined it. And so before we want to follow these traces, I only would like to say short what happened then. During World War II, Hartley was involved in so-called war works, and he was included in projects to prepare the bombing tables for the US Air Force and for their flying missions over Germany and occupied Europe. And only after World War II, Hartley got an academic position. In 1946, he became lecturer in statistics at University College London. And because the opportunities for statisticians were much better in the US, he moved in 1953 to the USA. His supporter, Comrie, died, so he was looking for a good job. And so in 1953, he moved to the US. First, he became visiting professor at the Iowa State College. And then from 1954 until 1963, he was professor of statistics there. And then he moved to the Texas A&M University. At the Texas A&M University, he created a school for statisticians, and I will quote Smith. He built his initial faculty in the Institute for Statistics from 4 to 16, and his students majoring in statistics from 10 to a maximum of 60. He attracted a considerable amount of research funds and directed more than 30 doctoral students in their research. And it followed a short-term visit professorship of mathematics and of community at the Duke University. And he received several acknowledgements, and in 1979 he became the president of the American Statistical Association. And before, he served as president of the Eastern North American region of the Biometric Society. And he died in 1980. Statistics on the table, that was the claim for Hartley, Hirschfeld, HOH. And which kind of tables we know? So from between the 16th and 19th, 20th century, we know this astronomical tables. Further on, tables were used in collecting and organizing raw data during experiments in many scientific disciplines, in physics, in chemistry, in biology, agriculture, and medicine. Parallel with this development, in the 18th and 19th centuries, mathematicians and scientists discovered that the elementary functions like powers, roots, trigonometric functions had their limitations. So solutions for important problems, for example, the orbital motion of planets, the calculation of the gravitational potential of nearly spherical bodies, it can't always be described in a closed form using only elementary functions. So functions describing solutions to these problems were very often expressed as infinite series or as integrals or as solutions to different equations. And so therefore mathematicians began in the 19th century to investigate these special functions from the pure theoretical perspective, and others constructed large tables with numerical values for the special functions. Tables on logarithm were used already by the astronomers, and perhaps you remember that you used them in the school time too, at least the elder of you. Today, because of the computers, it's still different. So it became important in the 20th century to produce handbooks with all these different tables of special functions and handbooks of mathematical tables. So for example, in 1968, the 16th edition of the handbook Standard Mathematical Tables was published. And this was a handbook, 600 pages, and included numerical tables, logarithm tables, tables for use in trigonometry, so sine, cosine, tangent, cotangent, etc., tables for series, Bernoulli and Euler, Riemann zeta function, tables for special functions, gamma, Bessel functions, elliptical integrals, tables for probability in statistics, and financial tables. The statistician who wrote the review on this handbook in 1970 mentioned, I quote, "The purpose of this book is to supply standard mathematical tables to students, and it is extremely well carried out with amazingly low price to the users." To this rule and rich history of table works and handbooks of tables, HOH belonged too. When he became a consulting statistician at the Harper Agricultural College, he started to make tables for these who worked there. And then when he joined the company Scientific Computing Service, recently founded by Cromley, so Leslie Cromley published 2 booklets on his company in 1937, 8 pages, and the address in that time was 131 Maze Hill, Blackheath. And 1 year later, in 1938, he published 16 pages, Scientific Computing Service, a description of its activities, equipment, and stuff. And probably this company is still existing in London, but of course, with a completely change of the staff, colleagues, and the work, what they are doing. So Hartley worked here until 1946 and became an expert in table making too. And both Cromley and Hartley published at least 2 articles together in 1941 on tables of percentage points of the incomplete beta function, and the other a table of Lagrange coefficients for harmonic interpolation and certain tables of percentage points. Hartley himself published more than 120 papers, and he made contributions to several fields of mathematics and statistics, and together with Arthur Greenwood, he made another table book, Guide to Tables in Mathematical Statistics. But most important is that he made together with Egon Pearson these 2 volumes of Biometria tables for statisticians, so tables for statisticians in the field of biology. The first volume came out in 1954, so shortly after Hartley moved to the US. The second volume came out only in 1972. But the first volume was reprinted and published several times. And I would like to quote from the preface, which was made to the first volume in October 1953. So this first volume was published 2 times in 1954, the edition and a reprint. It was again published in 1962, and again a reprint was published. So obviously this volume was a very successful one. And Pearson and Hartley dedicated the volume, I quote, to all those who help to compute numerical tables which reduce the labor of statistical arithmetic. And in their preface, they wrote that it was under the encouraging guidance of Cromley that the present compilers were brought together. And on the structure of the book, they wrote, I quote, "The compiler of a book of mathematical tables has always to face a somehow difficult problem in deciding the character and scope of the introduction. Broadly, we have tried to write our account so that within each of several connected sections, the definitions and descriptions are developed in a rough logical sequence. The table user will often only need to refer to a page list of contents to locate the table which he knows he wants. But insofar as he does wish to see as a whole the range of tables we are providing, we have tried to write so that he can get a connected and orderly picture by consecutive reading of the introduction. We have kept in mind a number of points, that a clear definition of the mathematical functions involved and of the links between them is essential. That in presenting tables to be used in drawing conclusions from observational data in terms of probability, some comment of the processes of inference can hardly be avoided. That tables provided to assist in the several stages of a lengthy computational procedure should be accompanied by rather detailed illustrative examples. That while the uses of many of the fundamental tables are too well known to call for much comment, there are other tables concerned with methods of analysis recently introduced which require fuller explanation. On the whole, therefore, it will be found that the more special and possibly lesser known tables have been rather fully explained and illustrated, whilst essentials only are given for the well-known standard tables. Thus, the allotment of introductory space is not closely related to the importance or expected usefulness of a table. And here you have one of these examples, how their tables look like. When Egon Pearson and Hermann Hartley wrote their acknowledgement for help to many computers, you please have to have in mind it was in 1953. They thought of persons, not of machines. And as usual in these times, many human computers were women. So I quote their acknowledgement: many computers, the persons, of all ranks have contributed to the construction of these tables. As workers in the early years, we may mention Shepard, Elderton, Ellis, Lee, and Scopper. In the later period, Catherine Thompson, Maxine Merrington, and Joyce May. One has to underline that the famous biometrical tables by Pearson and Hartley in the first volume were made without any high-speed computers. Only volume 2, which was published in 1972, draws heavily on computer-generated tables from many sources. And Aaron David wrote the 2 volumes with their attractive layout and useful introductory material are models of table making. So this is the second volume, and this is one example how the tables look then. So Hartley himself wrote some papers of the use of calculators and computers, and I think because you know a little bit now how he came to that computing service of Comrie and what he learned there, it's understandable that he was interested in very much in the development of machine computers, not human computers. So in 1980, shortly before his death, Hartley had given the presidential address on the annual meeting of the American Statistical Association as its president. And because he died very soon, then later than, one could read it also as his legacy. And beginning with the question, what is statistics, Hartley discussed 6 topics. And you see the first here on the slide. So that the science of statistics and the balance between mathematical and applied statistics, the cooperation between statistician and subject matter specialists, the problems of data acquisition, the impact of computer on statistics, and finally, the identity of the statistical profession. To understand the personality of Hartley, it's interesting to mention here that in this address, he quoted 2 times Sir Winston Churchill. Churchill, from May 1940 until July 1945, Prime Minister of Great Britain and one of the leaders of the anti-Nazi alliance during World War II, and the wartime was still important for Hartley. But we don't know whether Hartley ever quoted Churchill's bon mot on statistics. The only statistics you can trust are those you falsified yourself. So I would like to close my introductory talk today with 2 longer quotations from this presidential address related first to the problems of data acquisition and the impact of computers on science. So first, the problems of data acquisitions. When you have in mind, it was said in 1980, but it's still an actual problem and a difficult one too. So the problem of data acquisition is, I believe, means hardly believe, the critical issue with which most professional statisticians must deal. And again, they are faced with the question, where can I get data or information on this or that or on the other? However, it may be distinctly risky to just identify a data source and then blindly proceed to use it. It is vital to also have information on the limitations afflicting such data sources. Limitations both with regard to coverage and content errors. This applies particularly to overseas sources, such as those compiled by the United Nations, for example. Such additional information on the limitation of sources requires, again, a cooperation with experts concerned with the data compilation. Most of the official statistic sources are derived from simply surveys conducted by federal and state agencies. Granted, there are many interesting mathematical problems arising from the design and analysis of sample surveys. And we have also to come to the problem, we have made a heroic effort to reduce the incompleteness of our data. We could be reckless to assume that there are no errors in the data that we have managed to acquire. In fact, over-intensive efforts to avoid non-response may, in certain cases, result in faulty responses. It is therefore of paramount importance that at all stages of data collection and processing, the quality of the data should be controlled. Such control is the scrutiny of data for internal consistency. High-speed computers are taking over more and more of these functions of data scrutiny, and so therefore he comes to the fifth point, the impact of computers on statistics. Modern statistics is heavily dependent on the high-speed computer. It is appropriate, therefore, to dwell more fully on the impact of computers on statistics. And as you say, it's no question that they will affect the computational aspects and they will reach the heart and soul of our science and technology. And will they influence the outlook? I think they will. So I have already mentioned the important role of computers in the acquisition and editing of data, he says, and then it is in fact one of the most challenging applications of high-speed computer technology. From a mathematical point of view, you have to have in mind he became first a mathematician. From a mathematical point of view, the problem of error detection is essentially unsolvable, simply because the number of all possible errors patterns is combinatorically of an astronomical magnitude. All of these techniques depend heavily on high-speed computer programs and could not have been executed without their help. But another miscue of computer packages arises from a naive acceptance of the model assumptions underlying the packaged analysis, and even more naive assumption that there are no errors in the data. Finally, I turn to a development that I hardly personally consider perhaps the most important impact of computers, namely their use in statistical model building. Classical statistical analysis once insisted on the use of mathematical models for which compact mathematical solutions could be found. There are many other instances in which numerical analysis can and will replace analytical solutions. Future research will therefore be able to search more freely for realistic models incorporating the full spectrum of information that is at the disposal of scientists, and indeed they will use the computer as a powerful tool in trying alternate model theories, all of a complex but realistic form, to advance their theories on empirical phenomena. Thank you.